Hi everyone, my name is Isaac Berry from Berry Science Lab, and today we'll be doing a nice analysis exercise involving what we call multi-indices. Alright, so a multi-index is quite simple. A multi-index alpha in d dimensions, alpha is just a d tuple. So that means that it's going to be a d tuple specifically of natural numbers and 0. So, for example, a multi-index of dimension 2 could just be 7, 5. Now we define several concepts related to these guys. First, length, which is just equal to the sum of their components. Second, taking a derivative in alpha. So alpha is technically of d dimensions. So if this function is from rd to r, I don't know. If this function right here is from rd to r, then this has a very special meaning. This is just equal to partial 1, or partial x1, partial x1, partial x1, alpha 1 times, partial x2, partial x2, alpha 2 times. All the way to partial xd, partial xd, alpha d times. Alright, and finally, you have the factorial of this multi-index. And what's that equal to? Just equal to the product, alpha 1 factorial, alpha 2 factorial, the product of all of the factorials of the terms inside the tuple. So two things we're going to figure out. Two properties. Firstly, let's show that if we are given any function f from rd to r, then we take d beta f, So if we have a specific function, x alpha, such that this is equal to x1 alpha 1, x2 alpha 2, xd alpha d, then when we write this out, we want to show that at the 0 vector, this is equal to 0 if beta is not the same tuple as alpha, or index, multi-index, and alpha factorial, beta factorial, if the two are the same. So how's that achieved? Well, here's what happens. Let's think about what this is going to look like. So this is going to give us partial beta 1, partial x1 beta 1 times, partial x2 beta 2 times, partial xd beta d times of x1 alpha 1, x2 alpha 2, xd alpha d. So we can just split these up, divide and conquer. Partial x1 beta 1 of x1 to the alpha 1, partial xd beta d, xd alpha d. Now here's what we have to realize. If for one of these terms, beta is greater than alpha, what happens? Why do I keep writing? What happens? Well, here's what's going to happen. You're going to have the alpha derivative of this is just going to be alpha n factorial, but you're still going to be taking beta 1 minus alpha 1, beta n minus alpha n, which is a positive number amount of derivatives of this. That's just going to be 0. Now, what happens if beta of n is less than alpha of n? Well, you just get this, which I believe is equal to... Wait. Okay, I'm just very prone to making mistakes, apparently. So, what we get here is just going to be, I think... So, what happens here? Well, remember that we're plugging in the 0 vector, which means that this is going to be equal to 0. And what happens when one term of a product is equal to 0? Well, it's just going to wipe out the whole thing, which means that if beta of n is less than alpha n for any of the n's, then the whole product is equal to 0, which aligns with what we have here. Now, how do we show that it's this if beta is equal to alpha? Well, if beta and alpha are exactly the same multi-index, what is this going to look like? Well, this is just going to look like alpha 1 factorial. Wait, so is this alpha? Oh, crap. Alpha 1 factorial, alpha 2 factorial, alpha 3 factorial, all the way to alpha n factorial. All right. So, or d factorial. Oh, God. So this is just equal to alpha factorial. But wait, this says beta, but beta is equal to alpha, so it doesn't matter, unfortunately. Okay, so now we'll prove something a little bit trickier. If we have a multivariable polynomial which takes every single tuple of dimension d and length k, and we have this, we have to show that am I remembering the solutions correctly? Oh yeah. Okay. So this is what we're up against. So how do we do this, essentially? Well, first we have to understand what the problem is saying. So we're summing up all tuples with the same length that act like this. So let's say we have a specific tuple, alpha overline, let's say. So alpha overline over here, what's this going to do? Well, one of the terms is going to look like this, since this is one of the tuples with length k. Okay, nice. So what happens when we take the alpha overline of this? Well, we already saw the results of doing this a while ago. This just gives us this, and then multiplying these will just give us c. Okay, But what about the other bajillion terms? Well, let's say we have some distinct alpha hat. So this is not the same multi-index. So at least one of alpha hat's terms is less than the corresponding alpha overline term. So, to see why this is true, assume this wasn't true, and every single term of alpha hat was greater than the terms of alpha overline. Well, then that would just make the length of alpha hat greater than the length of alpha overline, which means that it's not going to be included in the sum. So, that means that this has to be true if alpha hat is included in the sum, which is the only thing we care about. So then, what is alpha hat's term going to look like? Okay, and now what happens? Well, what happens when we take the alpha overline of this guy? Well, one of those terms, let's call it the nth term, one of the terms in this product is going to falter. So you're going to get d alpha n. No, this is not how. So you're going to get this. But our assumption is that n is one of the indices where, and of course we all know how this goes, which means that every single term other than the one that matches up right here, which gives us c, is going to go to 0. So you're just going to have a c of zeros and then c, which reduces down to c pretty comfortably, which means that this is true. So taking the derivative with respect to this one of the multi-indices in the sum will always give you that constant sitting right there.